Yeah, here we have taken three examples for McCulloch's neural network model. So here I have taken AND logic, OR logic and AND NOT logic. Okay, so what we're going to do is all the connections look similar, like you have x1, x2, based on that you have an output value. It is AND of x1, x2, and here it is OR of x1, x2, and here it is AND NOT of x1, x2. Okay, so here all the structures are similar. You have two input neuron, one output neuron, and your architecture will look like this. You have this x1, x2, and you have your y here. Okay, and it is fully connected, and neural network structure will look like this. You have your input neuron and you have your output neuron. Okay, so it is y out. And what you're going to do, you're going to find a particular weight value for these two neurons and one threshold value. Okay, so you can decide on any values, like it is going to be a randomized value until you stabilize itself. So here the McCulloch bit is a normal basic model where you don't have an algorithm or a procedure for doing it. So you have to adjust the weight yourself so that it matches with the output structure of it. Okay, so what we have to do, we have to find the weight value and we have to find a threshold value, for which threshold your logic sets over. Okay, so first I'll start with the basic one. So let me just guess with the input values as 1. Okay, so what if my weight are 1? I have to check for each and every possibility. Okay, so here I am going to write it in this place itself. I am going to find what will be my y in, y out. Okay, so y in is the input that is going to get it through y. Okay, I have to take each and every value of x1, x2 and we have to combinedly calculate this y value. So that will be a y in. After threshold, you'll have a y out value. So this threshold we have to set it up. So first I'll just decide on calculate all y in value. Since we have already randomly assigned some values for w, a weight vector, so we can directly calculate y in, and whichever is suitable, we can choose that as your y out, a theta value, a threshold value. Okay, so first I'll start with my first input pattern. If my input neuron has value as 0, the first pattern, the next x2 also 0, x1 is 0, x2 is 0. Now when I am calculating it, how I calculate your y value? It is the input into weight. 0 into 1 is 0, and here also it is 0 into 1 is 0. So 0 plus 0 is going to be 0 over here. Okay, so just I am going to pass the input, calculate your output. So here it is, calculation is like this, x1 into w plus x2 into w. So this will be your y in value. Okay, so the first neuron, it takes both x1 and x2 are 0, your result is also 0. Now take the next path. So x1 is 0 and x2 is 1. So what your value will look like? 0 into 1 is 0 plus 1 into 1 is 1. So your output is 1. Okay, and for the next pattern, you have to check for all possible pattern. Okay, so the net has to stabilize for all possible pattern. So you have to set a threshold in such a pattern, or you have to set the weight vector in such a pattern that in future when I set this input, it automatically recognize or give the output of AND logic. Okay, so first two it is done. Third one, when x1 value is 1 and x2 value is 0. Okay, so it is 1 into 1 is 1 plus 0 into 1 is 0. So your output is 1 here. Got it? So the last neural network model, like you had input pattern goes like this. First one is 1 and x2 also take the value of 1. So it is 1 into 1 is 1 plus 1 into 1 is 1. So 1 plus 1 is 2. So this is the input that is received for y. Now I have to check a threshold value such that this pattern has to be matched. Okay, so I want 1 when the value is 2. Okay, only for this portion I want the output to be 1. So when I set the threshold value as 2, whenever your output is greater than or equal to 2, your neuron fires, your output will be matched. In other cases, you can set it as 0. Okay, so when you set your threshold as 2, only this portion, when you send the input as x1 as 1 and x2 as 1, your neuron is going to be fired and your output you are going to receive it as 0. sorry 1. In other side it is going to be 0 for all. Okay, so now the net is stabilized, right? So for whatever the input pattern you give, your output will be 0 or 1 according to your AND logic. So this is how you have to proceed on. The ultimate goal of your McCulloch split neuron is decide on a weight vector and decide on a threshold value. Okay, I will show you the next example too so that you will understand it better. So the next example is also for OR logic. I am going to have two neurons here, x1 and x2, input neuron, and y is my only output, and layer is set like this, a fully connected neuron, and I am going to send the inputs here. Now again it is going to be the same. I have to find the weight value for it. So let me just take the same weight value over here and I am just going to check what will be my y out is. Okay, what will be my y input? After your threshold, we have to find it out. Okay, since it is same as that of the previous model, your y in is going to be the same. So I can take this as the y in as same as this. Okay, since you have two neurons, same two neurons, weight is assigned as 1, weight is assigned as 1 over here, and the input pattern is also same. So this is my y in value. Y in value is going to be common. Like when I just send 0 here, your output will be 0. When I set 1 here, 0 here, your output will be 1. 1 here, 0 here, your output will be 1. And both ones you will get 2. Okay, since I haven't changed the model as it is, I have changed the weight as it is, and I haven't changed the input pattern. So I am going to get the same output. Okay, but now I have to find the value for threshold such that it works only for OR logic. Okay, and what is the expectation of your OR logic? When only for this category I want 0. For all the remaining patterns, I want the output should be 1. Okay, so I can set a threshold as 1. When the threshold value is more than 1, your neuron fires. That is, your output can be taken as 1. Okay, now it matches. See, for 0 it is going to be 0. When it is more than 1, your output you are going to send it is 1. Okay, so now I got the same exact output that is needed for OR logic. Okay, so this is how a McCulloch split neuron works. Now the last category is ANDNOR. This is somewhat specific, like it is not like the same as that of your previous one. I cannot set 1 1 here. Okay, you know why? When I set 1 1 here, I get the same y in value as 0 1 1 2. But I want this neuron alone to be fired. In the output, I just want the middle portion alone to be fired. But there is no possibility of it, right? I cannot set the threshold as 1. For anything greater than 1, all this value will be 1. But my output, I just need one single portion of this unit alone to be 1. Okay, so you have to find all possible weights over here. It is not just by changing the threshold, your input will be activated. You want to find a specific place where you can apply a specific weight vector for it. And remember, your weights need not to be always excitatory. You can have a negative inputs too. Okay, negative weight values too. Okay, you can have inhibitory weight unit. So let us try with something like this. I'll take x1, x2 and y here. While assigning the weights, as I told you, I cannot go ahead with 1 1. Okay, when I am going ahead with 1 1, I cannot set a proper threshold over here. So I have to take some negative value somewhere. So let me just check with -1 here and 1 here. Okay, so what will happen when I set it as -1? Like I'll just calculate it here. I can write y in function here. This is random, like I can check for other possibilities too. So first possibility is when my x1 is 0, y1 is 0, it is going to be getting 0. 0 into -1, 0 into -1 is 0. Okay, and for the next category it is 0 for x1 and x2 is 1, and how the weight is calculated? 0 into -1, it's 0, and 1 into 1 is 1. Okay, this is for second category, and for third category I can write it as x1 as 1 and x2 as 0. Okay, so your input will go as 1 into -1 is -1 and 0 into 1 is 0. So it is going to be -1 here. And for the last category it is 1 1, 1 into minus 1, it is minus 1 plus 1 into 1 is 1. It is going to be 0. Okay, again you cannot set any threshold over here. See, when I set a threshold of greater than or equal to 0, only this goes 0. All will be 1. I don't want that, right? So I have to reverse the weight. So this is not applicable since I want this element's output should be greater than all others. Then only I can set a threshold, proper threshold for it. So what I can do is, this is a wrong way of assigning the weight. It is not working it out. So I can just reverse the weight values. Okay, rather than just taking minus 1 and 1, I can take it as 1 and minus 1 here. Okay, now let us check the input again. For 0, 0, it is going to be 0. 0 into 1 and 0 into minus 1 is going to be the same. For 0 and 1, when x1 0 and x2 is 1, it is 0 into 1 is 1 and 0 into 1 is 0 plus 1 into minus 1 is minus 1. So your output is minus 1 here, and when I take the next input, it is 1, 0. Okay, so 1 into 1 is 1 plus 0 into minus 1 is minus 1. Sorry, 0. So your output is 1. Okay, and for the last one, it is going to be 1, 1. So 1 into 1 is 1. 1 into minus 1 is minus 1. The output is 0. Okay, so now I think I got the category. 0 for this place, it has the higher value. Okay, so when I set the threshold as 1, all the remaining inputs has the value less than 1. So I will get the output over here. So for y out, when I set the threshold value as 1, when your y in is greater than or equal to 1, your output will be 1. So 0 is less than, minus 1 is also less, it is greater than or equal to. So I can just get the output as 1 here and 0 here. So this exactly matches with the output that is needed. Okay, so this is how a McCulloch neuron works. So you have to check for all possible threshold and all possible weight vectors. And here you can be either it can be an excitatory input or a inhibitory input based on the weight vector that you have assigned for it. Okay, so this is one example, a few sample examples, and sometimes your McCulloch neuron can be extended to some extent of some other hidden layers in between. Okay, I'll show you an example of another function where you cannot predict this output value in just one go. Okay, so these are all the places where I have a possibility of finding the values, but sometimes you may have a possibility of not able to find the output value or not able to fix a threshold value just by adjusting these two weights alone. So in that case, I can extend this by adding some extra layers to it. Okay, so next example I'll show you that. Thank you.